Now, in this lecture, we'll study interrupts in 8085. Now, what is interrupt? Interrupts are signals generated by the external devices to request the processor to perform a task. Now, in 8085, there are five interrupts are there. The one is trap, RST 7.5, RST 6.5, RST 5.5, and INTR interrupt. Now, classifications of interrupts. So first one is a vector interrupt. In this type, now first one is vector interrupt. In this type of interrupt, the interrupt address is known to the processor. For example, 7.5, 6.5, 5. RST 7.5, RST 6.5, RST 5.5, and trap. It is having the fixed vector address. Now here you can see trap is having the 24H is the vector address, 5. RST 5.5, 2C, RST 6.5, 34 or 34 or RST 7.5 3C. Now these are the vector addresses which is known by the processor. Whenever these interrupts generates directly, processor will go to this address. Now coming to the non-vector interrupt. In this type of interrupt, the interrupt address is not known to the processor, so the interrupt address need to send externally by the device to perform the interrupts. For example, INTR. INTR is a non-vector interrupt. Now, in the unit 1 also we have studied that whenever it is sending the interrupt, after receiving the acknowledgement, then again the device will send the address on the vector address on the data bus. So now this is about the INT. Now coming to the next one, maskable interrupt. In this type of interrupt, so we can disable the interrupt by writing some instructions into the program. For example, so now these are the maskable examples, maskable interrupts. So RST 7.5, 6.5, and 5.5. So these can be masked by using the processor by writing few instructions that we will see in the in this lecture, the last. Now, non-maskable interrupt. In this type of interrupts, we can't disable the interrupt by writing some instructions into the program. Example, trap. Trap is a non-maskable interrupt. If it is generated, processor must execute the ISR of the trap. Software interrupt. Now, best example for the trap is what? A power failure is a example for the trap. Now, software interrupt. Now, in this type of interrupt, the programmer has to add the instructions into the program to execute the interrupt. Now, there are total 8 software interrupts are there. So RST 0 to RST 7, total 8 type of RST is nothing but what? Reset. So total 8 software interrupts are there. Now coming to the hardware interrupts. Now these are 5 interrupts. 5 interrupt pin in 8085 used as a hardware interrupts. Those are trap, RST 7.5, RST 6.5, RST 5.5, and INTR. Here it is not INTA, it is INTR. And INTA is the acknowledgement signal to the INTR. Now coming to the trap. Trap is a non-maskable interrupt having the highest priority among all the interrupts. By default, it is enabled until it gets acknowledged. So processor must execute the trap instruction. In case of power failure, it executes the ISR and sends the data to backup memory. This interrupt transfers the control to the location 24. Now, whenever this trap interrupt occurs, so automatically processor will jump to this location. Now, next one is RST 7.5. It is a maskable interrupt having the second highest priority among all the interrupts. When this interrupt is executed, processor saves the content of the PC register into the stack and branches to the 003. This is a vector address for the RST 7.5, and it is a non-maskable interrupt and second highest priority. So coming to the RST 6.5, it is also maskable interrupt having the third highest priority, and it will also save the content of PC register into the stack, and it will branches to the 0034. This is the vector address for the RST 6.5. Now RST 5.5 is a maskable interrupt, which is when it is interrupt is executed, the processor saves the content of the PC register onto the stack and branches to the 0020. Now INTR is a maskable interrupt and having the lowest priority among all the interrupt, and it is a non-vector, and it can be disabled by resetting the processor. This is about the interrupts. Now we will see the rim and sim instructions. Now these interrupts can be set and read the status of the interrupt by using this rim, sim and rim instructions in 8085. So first is sim. Sim is a set interrupt mask. So now by using this interrupt, we can set the interrupts, and also we can send the data serially out by using this SOD pin from the microprocessor. Now it is a 1 byte instruction used for both the purposes, to set the masks and to send the data serially out. Now if you see, this is A0, this is the data, 8-bit data, or 8-bit accumulator. Actually, we are storing this value into the accumulator and we are using the sim instruction. So now this is the data which is stored into the accumulator. So 8-bit data, that is nothing but D0 to D7. These are the total 8 bits. Now if we see the bit number 3, when this bit number 3 is equal to 1, then mask is possible. We can mask the interrupts. So these three, so masking of 5.5, 6.5, 7.5 can be done only when the MSE mask set enable is set to the 1. If it is 0 means what? These 3 bits are ignored. So now after, if this bit is equal to 1, then according to the value, now if these values are 0 means what? It is unmasked. If it is a 1 means what? Masked. So we can set the interrupts, whether those interrupts are masked or unmasked. Now, pin number 4 is resetting the 7.5. So by using this, if it is equal to 1, we can reset the RST 7.5. And pin number 5 is unused, and SOE, enable serial data. If this pin is equal to 1, then data can be sent out serially by using the pin number 7. If this is 0, then this 7th bit is ignored. This is about the sim instruction. Now coming to the rim instruction, again this data is loaded into the accumulator, and this is also 1 byte instruction. And for the reading the status, this is used for the reading the status of the interrupts, and also can read the data serially. So serial data in means what? Processor will read the data serially by using the pin number 7. Now if you see the pin number 0 to 012, here whether these bits are masked or unmasked, we can read by using these 3. And interrupt can be enabled by using this IE. And if any interrupts are generated and those are not serviced by the processor, so if it is pending, then the pending status can be read by using the pin number 4, 5, 6. 4 is for the 5.5 RST, interrupt 5.5, 6.5, and 5 is 5.6.5, and 6 is for the 7.5. If it is 0 means what? No request is pending. If it is 1 means what? Interrupt request is pending. Now this is about the rim instruction. So with this we have finished the interrupt concept.